In this video, we're simplifying expressions that have radicals. For this first one, it looks like they want us to multiply. So I want to go over a basic idea of multiplication when dealing with radicals. The rule is simple. So if I had something like 2 times the square root of 3x times 4 times the square root of 2y, the rule is simple. We multiply the coefficients in front, or the numbers outside get multiplied together. So that would be 2 times 4 is 8. And then we multiply the inside pieces, the pieces that are inside or under the radical, together. So we'll have 3x times 2y, or in other words, 6xy under the radical. And that's how you multiply radicals. Now, in the example we have here in example A, we only have coefficients of 1, so that's not too bad. So we just multiply the insides then. So I'll have 4 times 12, which of course will give you 48. And then I have x cubed times x to the 1 power. When you multiply two terms with the same base, you keep that base, remember, and you add the exponents. So 3 plus 1 will give you 4. All right, all that's under the radical, though. All that's under our square root. So from here, we have to simplify that. So in order to simplify it, we can, again, factor, right? So in order to factor this, we want to try to break it up into things that have pairs because this is a square root, right? So 48 can factor as 2 times 24. And then from there, of course, 24 can be factored as 2 times 12. And then 12 is 2 times 6. And then 6 is 2 times 3. And then we factored it all the way down to primes. So when I summarize that underneath my square root, I can say that it's 2 squared times 2 squared times 3 times x squared times x squared. So what I've done here is I've simply broken up the x to the 4th as x squared times x squared, and I've expressed 48 as 2 squared times 2 squared times 3. Now the reason why I wanted to do that is because remember, for every pair of items we can take one outside. So I can take one of these 2 squareds outside. Of course, 2 squared is the same as 4, so that'll come up as 2 squared, which I'll simplify as 4. The 3 is all alone in here. It can't get out because it has no partner in crime to escape with. So we're just going to leave 3 inside there. But the x squareds, they can come out, right? I can take out 1 x squared for the 2 of those that are in there. Then I have the square root of 3 left over. So my final answer for this is going to be 2 squared, which is 4, times x squared times the square root of 3. Okay, let's look at example B now. So it's multiplication of radicals again. So the coefficients will multiply by the coefficients, right? Outsides times outsides, in other words, right? So that'll give you 2 times 5, which of course is 10. And then we'll have the inside pieces times the inside pieces. So 15x times 3x squared, all under the radical, will give us, well, 15 times 3, of course, is 45. And then x times x squared will give you x to the 3rd. So that's the product, but now we should simplify our answer. So in order to simplify our answer, we're going to go ahead and say that the 45 is just 5 times 9, and x to the 3rd is x times x times x. Now from there, we can say 10 times the square root of 5 times 3 times 3, and then times x times x times x. And lastly, we're able to take out anything that has a matching pair, right? So it looks like I can take out a 3 outside here. And remember, that 3 is going to multiply by whatever's out there already. So 10 times 3 is going to give you 30. And then an x can come out as well with that. So we're going to have 30x. Inside the radical, we'll still have a 5, and we will have an x that can't get out because they don't have a partner to escape with. So we end up with the answer 30x times the square root of 5x. Okay, so that's it. Now let's tackle example C. All right, so in order to tackle example C, we're simply going to first recognize that we can't multiply these two radicals directly because they have different indexes. One is a 3rd root and the other is a square root. So what I'm going to do in this situation then is to first evaluate the square root of 9, and that will work out to be 3, of course, right? So we'll end up having 3 times, right, the cubed root of 5. and all of that will be raised to the 4th power. Now, there are several different approaches that would help us finish this problem, but I want to go with the most simple, basic approach that we can find. Because I think, rather than introduce some other concepts at the moment, let's go ahead and work with the most basic thing we know and to see if that helps us do the problem. So for example, when something's raised to the 4th power, it means write it down 4 times, right? That means we will literally have 3 cube roots of 5 times 3 cube roots of 5 times 3 cube roots of 5 times 3 cube roots of 5. Now there will be a simpler way to tackle this. In the next video or two, we'll cover that. But for now, it's perfectly fine to do this. This will work. 3 times 3, of course, gives you 9. And 3 times 3 here will give you 9. So that's 9 times 9, or in other words, 81. Or 3 to the 4th power is 81. However you want to do that is fine. Now from there, you know the rule about multiplying radicals like this together. If they have the same index, we can just multiply all the insides together, right? And keep it inside. Well, if I write that out, that'll be the 3rd root of 5 times 5 times 5 times 5. Remember the rule, if we have a 3rd root and we have something that's repeated 3 times under the radical, we're able to take out one of those out in front. So we're going to end up having a 5 come out here and multiply by the 81. So we'll have 81 times 5 times the 3rd root of, there'll still be a 5 left underneath, right? So the 3rd root of 5. Okay, and then lastly, we just have to do the arithmetic here. Well, 5 times 80 would be 400, and then we'll have an extra 5, so it's going to be 405. Cube roots of 5. And that's our final answer.